4, we're going to put it all together finally. And in the 4th template, we're going to learn how to graph. So we're going to kind of take from what we learned in 6.3. But basically, we are learning polynomials of higher degrees. The bigger the polynomial, the more zeros. The zeros is where it crosses the x-axis. Okay, so how did we figure out how they cross the x-axis before? You set that equal to 0, and you set this one equal to 0. 1 is one answer, and -4 is another answer. But do you see that there's 2 of them, and only 1 of them? So if I put this all back together again, this would be degree of x to the 3rd. The parentheses right here should add up to 3 because that's how many zeros there are. Okay, let's do this one. 3 is an answer and -4 is an answer, but there are 18 3's and there are 28 -4's. That's called the multiplicity, which means how many of them. Let's do a couple more. There's an x attached to this one, so if you set it equal to 0, you're going to get 0, and you're going to get 1 of them. One answer is 3, and you're going to get 3 of them. And this one, if you set it equal to 0, you're going to get a -1/2, and there are 4 of them. So if I put this all back together again, this one right here, this one right here, and this one right here adds up to the 8, which means this polynomial would be x to the 8th power, which is important to understand. And the last one, set this equal to 0. There are 3 of them. So that's the first part of the assignment, figuring out the zeros. The second part is just to write a polynomial in standard form. So they just want you to multiply these out. This will take a while. There's not just one x plus 3, there's 2 of them. So I'm going to multiply this out first. You get x to the 2nd plus 3x and 3x gives me 6x plus 3 times 3 is 9. So that's what x plus 3 times x plus 3 equals. And now this is going to take a little bit longer. X times x is x to the 3rd. X times 6x is 6x to the 2nd. 9 times x is 9x. Then you're going to multiply by a -2, a -2x to the 2nd, a -12x, and a -18. Final answer, x to the 3rd. I can put these two together to make a +4x to the 2nd. I can put these two together to make a -3x minus 18. Okay, this one's even going to take longer. I'm going to put these two together first and these two together first. I'm going to get x squared minus 2x by the distributive property. And this one's going to give me x squared plus 3x and 2x gives me 5x plus 6 by the FOIL method. And then we have to do what we just did in the last problem. Y equals x squared times x squared is x to the 4th. X squared times 5x is 5x to the 3rd. X squared times 6 is 6x squared. -2x to the 3rd. -10x to the 2nd. -12x. Then you have to simplify this. It's going to be x to the 4th plus, these two can be put together, 3x to the 3rd. These two can be put together, -4x squared minus 12x. Final answer. So if I put these all back together again, my highest degree is 4. So that's the second part of the assignment, putting it back together again. Now we're doing the opposite. We have to make a polynomial. If 0 is an answer, this has to be an x. If 1 is an answer, it's going to be x minus 1. And if -2 is an answer, it's going to be x plus 2. And then they want you to write a polynomial like we just got done doing. So y is going to equal, I'm going to put these two together first.
Can I have your attention, please? The internet is back up and running.
going to get x to the third plus x squared minus 2x. Final answer. I know I have 3 answers, and my highest degree is 3, that I'm doing it correct. One more of these. I know that 3 is an answer. I know that 3 is an answer. And I also know that x minus 3 half is an answer. Okay, we have to change this one, so I need to multiply this by 2. So I'm going to get 2x minus 3, because I don't want a denominator when I'm multiplying polynomials. So whatever the denominator is, you have to multiply only that fraction by what the denominator is. Okay, now I'm just going to go ahead and multiply these two together. That's why we're spending 2 days on this. This is very time consuming. You have to take each one of these and multiply it by 2x. So 2x to the third minus 12x to the second plus 18x. You also have to multiply them all by a negative 3. Negative 3x to the second plus 18x minus 27. And then you have to put this all back together again. 2x to the third minus 15x to the second plus 36x minus 27. So the first part, just go back to that. That's easy. That's just finding the answers. That's not going to take long. But these two are, the next two templates are very similar. Now comes the graphing part. Here we put it all together. We need to know the end behavior. And remember, there are 4 of them. If they both face up, it's a positive even. If they both face down, it's a negative even. If one faces down and then faces up, it's an odd. One faces up and it's down, it's an odd. If this one's a positive odd and this one's a negative odd. So you have to know the end behavior. That's one thing. You also have to know the multiplicity and its roots, and if it's an even or an odd. And if it's an even root, it's going to bounce off of the point. And if it's an odd root, it's going to go through the point. So this is very long and confusing. That's why we're going to end up doing 3 of these to help you understand. So if I were you, I would do all of these exactly the same way, this last part. So here we go. Okay, the first thing I'm going to write down are my roots. And if I were you, I'd go step by step like me. 2 is a root. I have 2 of them. Negative 1 is a root, and I have 1 of them. And a negative 3 is a root, and I have 1 of them. So that's the first thing you should write down. And where did I get this from? I got this from the first page of writing the zeros and the multiplicity. The next thing I'm going to do is I am going to circle these and add them up. That adds up to 4. That adds up to 4, which is an even power. And I have a positive 1 for my coefficient. My leading coefficient is a positive 1. So it's positive and it's even. It's going to be both facing up. Okay, so here we go. I'm going to put a dot at 2, a dot at negative 1, and a dot at negative 3, because this is where it crosses the x-axis at, the ones that are not circled. 2, negative 1, and negative 3 are called the roots. I know my end behavior, the ends of my N2 dots end up. but I have to figure out what it does in between. So, this is the way it works. You're going to look at now these numbers. If it's an even number, it bounces off the point. If it's an odd number, it goes through the point. So let's look at the first number to the left. It's a -3 right here. This is an odd number. 1 is an odd number. So I'm going to go through my point. If it's an odd number, I go through the point. If it's odd, I go through the point. And if it's even, it's going to come here and it's just going to bounce off of it. Odd goes through a point, even bounces off. So the next number is a -1, and this is an odd number. So I'm going to come over to a -1 and I'm going to go through the point, just like this. And then the last one is a 2, and that's an even number. So I'm going to turn and get over to the 2. And do you see how it bounces off with a dot? And that's my final answer. That's what the graph of x minus 2 to the second times x plus 1 times x plus 3. Okay, let's do another one. The first thing I'm going to do is list my roots. I know a -1 is one of my roots. How many negative ones? 2 of them. I know that 1 is a root. I only have 1 of them. And I know 2 is a root. And I have 1 of them. The underlined ones are called my roots. So I have to put a dot at 2. I need to put a dot at 1 and a dot at -1. Those are my roots. I know when I add up the parentheses that it adds up to 4. And that's an even number. And the number out in front, my leading coefficient, is a 1. So this one faces up, starts up and ends up. Okay, so I know that my last 2 dots start up and end up, but what does it do in between? So let's start at -1. Here's a -1, and notice that this is an even power, so this dot is going to bounce back up. And then I'm going to curve to get to the next one, which is a 1. This is an odd number, so it goes through the dot. And number 2 is an odd number, and it goes through the dot. Final answer. Okay, let's do another one. Whoops. Zero is one of my answers, only one of them. -4 is another answer, and only one of them. Those are my roots. If I add these 2 up, I get 2, so that's my highest power, so it's even. But my leading coefficient is a -1. Everybody see that my leading coefficient is a -1? So it's going to start down and end down is my leading coefficient, is a negative number. I'm going to put a dot at 0. That's one of my roots. And -4 is my other negative root, -4. I know it needs to start down and end down, but what does it do in between? Well, they're both odds. 1 and 1 are both odds. You're going to go through the dot, and you're going to go through the dot. Final answer. It all kind of goes together, how it starts and ends. I'm going to do one more. I don't know what this is doing, but I'm going to do one more, and we are done. Okay, last problem. My roots. 0 is one answer. Let's make this to the second, and let's make that one to the second. Okay, so 0 is one answer, and there's only one of them. -1 is another answer, there's 2 of them. And 2 is an answer, there's 2 of them. If I add these all up, it's gonna be to the 5th power. And my leading coefficient is a -3. So this is odd, and it's also negative. Odd and negative starts up and ends down. An odd negative starts up and ends down. So I know that 0 is a solution. I know that -1 is another point where it crosses the x-axis, and I know that 2 is the last spot where it crosses. And I know on the left it starts up, and on the right it ends down. So it starts up and ends down. I know that that's what that looks like, but what does it do in between? So at a -1 right here, this is an even number, so it's gonna bounce off of a -1. At 0, this is an odd number, so it's gonna go through the dot. And 2 is an even number, so it's gonna bounce off, and that's exactly what that graph looks like. Okay, I did an extra example for you to help you understand it. And those are the notes for 6.4.